In today's video, we'll be learning part 3.3, how do metals and nonmetals react in chapter 3, metals and nonmetals. In the last lesson, we learned how metals react with air, water, acids and other metals. In this lesson, how metals react with other nonmetals. The reaction between metals and nonmetals usually occurs through transfer of electrons, which results in an ionic compound. And the bond that is formed is called an ionic bond. Let's try to understand this further using the example of common salt or table salt, which is sodium chloride. As we can see in the image here, sodium is a metal and chlorine is a non-metal. Sodium has an atomic number of 11, which means its configuration is 2, 8 and 1. So it has one valence electron in its outermost shell. Now chlorine has an atomic number of 17, which means it has 7 electrons in its outermost shell, or it has 7 valence electrons. Now we know that atoms try to gain stable configuration by achieving a complete outer shell or a full outer shell. For that, sodium has to give away 1 electron, whereas chlorine needs 1 electron. Now when sodium gives this 1 electron, it becomes a sodium ion. Remember, it is very important to know that an atom becomes an ion only when it gets a charge. So an atom gets a positive charge only when it gives away an electron. So sodium gets a positive charge and becomes a cation. On the other hand, chlorine receives this electron and becomes an anion. Now sodium and chlorine have become cation and anion and have opposite charges. Now this opposite charge creates an attraction between these two due to electrostatic forces, and due to the strong attraction force, they become an ionic compound, which is sodium chloride. In order to understand how these metals and non-metals are reacting to form these ionic compounds, let's look at some more examples. Let's take a look at the periodic table first. So you know, in periodic table, when you move from left to right, what happens is the number of valence electrons in the outermost shell is increasing. So group 1 and group 2 usually have 1 and 2 valence electrons, whereas group 16 and group 17 have 6 and 7 valence electrons. So in group 1, we have 1 valence electron in the outermost shell, whereas in group 2, we have 2 valence electrons in the outermost shell. On the other hand, in group 16, we have 6 valence electrons, and group 17, we have 7 valence electrons. So now these group 1 and 2 react with this group 16 and 17 to form ionic compounds. Group 1 and 2 consist of metals, group 16 and 17 are non-metals. These two are reacting by transferring electrons to form ionic compounds. Let's take a look at another example in order to understand how this transfer of electrons is working. For example, we have magnesium here. So magnesium has an atomic number of 12, that is, it has a configuration of 2, 8, 2. So outermost valence electrons are 2. On the other hand, oxygen has a atomic number of 8 and it has 2 and 6. So oxygen needs 2 electrons and magnesium has to give away 2 electrons in order to become stable. Now this results in magnesium giving away its 2 electrons and becoming a cation, and oxygen becoming an oxide by taking those 2 electrons, or a cation. That is, it is becoming a cation. Now this anion and cation again get together because of the strong electrostatic forces, and they form an ionic compound, which is magnesium oxide. Now let's take a look at some properties of these ionic compounds. As we discussed, the bond that is formed is ionic bond, and products are called salts like calcium chloride, magnesium chloride, sodium chloride and so on. And the reaction is usually exothermic, that is, a lot of heat is released. Let us look at why this lot of heat is released. Now what's happening initially is a cation is forming, right? That is, an electron is being given away. Let's take the example of sodium chloride itself. So sodium is giving away an electron, and this process usually results in absorption of energy. So we are starting with absorption of energy, and when anion is accepting these electrons, energy is released. So there is some absorption of energy, some release of energy. However, as I said, there is electrostatic force that is bringing it together to form ionic compound. When this compound is being formed, a crystal lattice is being formed from these two atoms, what happens is there is a lot of energy that is being released. A large amount of energy is released when this lattice is formed. So overall, when you see, the amount of energy that is released is really high, making this an exothermic reaction. Another property of these ionic compounds is that they are hard and brittle. If you can touch salt and see, you can see that it's really brittle and it is also hard. At the same time, it also has a high melting point and boiling point. Now, why this high melting point and boiling point is again because of the formation of this lattice. Now, as I said, there is strong electrostatic force, right? Now, if you want to break the lattice, then you have to break the strong force. In order to break the strong force, you need high amount of energy, which means high melting and boiling points. Another property of these ionic compounds is that they do not conduct electricity in solid form, but when they are molten or when they are in their aqueous form, that is when they are dissolved in water, then they will conduct electricity. Now you might think, but salt, how does it dissolve in water, right? Because it has a strong electrostatic force. If it doesn't melt but it dissolves, how does that happen? So what's happening here is when salt is mixed in water, water is a polar molecule. What is a polar molecule? That means it has both positive and negative charges. Water has hydrogen and oxygen, right? H2O. So oxygen carries positive charge and hydrogen carries negative charge. And these charges are partial positive and negative. What happens when you add salt to this? Salt also has Na plus and Cl minus. Now Na plus gets attracted to the negative charge, that is on oxygen, and Cl minus gets attracted to positive charge, that is on hydrogen. So because these positive and negative charges attract and separate these ions, now these ions are present in water, surrounded by water in fact, in their hydrated form. So we say Na plus and Cl minus are no longer bonded with the ionic bond, but they are separated and are present surrounded by water in their hydrated form. Now what happens when they are present like this? If you insert a anode and cathode, there is a movement of these free ions. So when there are free ions in water, they move, and through this movement there is a movement of charge. Movement of charge is nothing but current. That is how these ions are conducting electricity. That's the end of part 3.3.